Good morning, this is your Stats Sensei, Mr. Spensei, and this is 3B.8 Z-scores in the normal. So a factory is producing energy bars, and the weights of the bars are normally distributed with a mean of 50 grams. That's super important. First off, it's super important they told us it's normal because that tells me right away I can draw a normal curve. So I'm going to go ahead and do that. It's like, all right, we have a normal curve, and we're telling me the mean is 50. Okay, that means we're centered on 50. I'll go ahead and label that mu for mean. And the standard deviation of 2 grams. Now remember, the normal curve is basically almost all of it, although it technically goes to negative infinity and positive infinity, we really have most of the data is within plus or minus 3 standard deviations. So 1, 2, 3, where this is -1, -2, -3. Then we have 1, 2, 3 going up, 1, 2, and 3. And they're telling us each standard deviation or each difference between those. And by the way, this should be 0. So I'm going to scratch this out and write 0 because all these are the z-scores. All the z-scores are in red. But then we have the actual mean of 50. And each standard deviation changes this by 2. Okay, and basically all these spacings are the same, and this is a number line. So the first one here is 52, then we have 54, then we have 56, and subtracting 2, we have 48, 46, and 44. It says what percent of the weights are between plus or minus 1 standard deviation? Well, guess what? It's always going to be the same for normal. That's one of the things that's special, and it'll be approximately 68%. So between plus or minus 1 without doing any calculations, we can estimate it at 68% because we're plus or minus 1 standard deviation. So we can go ahead and write that down. All right, so that's our normal curve. But for this particular problem, it says, what is the lower bound for plus or minus 1 standard deviation? Well, the lower bound, we're just subtracting 2, so that's 48. So here's our mean, and then we're subtracting 2 to get to our lower bound, and we know that this distance right here is 68% in total. You know what? I'll mark it up here. This is 68%. And then it asks for us what is the upper bound? Well, we're just adding 2 to that 50. So 50 plus 2. So just adding the standard deviation. So it's the mean 50 minus 2. That's my lower, and my upper is 50 plus 2. And that's where those come from. Okay? All right. The next one. As factories producing energy bars and the weights of the bars are normally distributed with a mean of 50. So we have the same thing with a standard deviation of 2. So we have exactly the same situation. We still have a mean of 50, standard deviation of 2. Sketch a normal curve with the mean and standard deviation that illustrates the empirical rule and fill in the blanks using the estimates from the empirical rule. Well, I already did that. And this was the empirical rule for plus or minus 1 standard deviation because that was the first question. The second question is what's plus or minus 2 standard deviations? Well, we need to memorize this. Super important to memorize this. Plus or minus 2 is approximately 95%. It's really not exactly, but it's close to 95%. So 68% plus or minus 1 plus or minus 2 is 95%. All right. So as we continue on, it says what's the lower bound for plus or minus 2 standard deviation? Well, the lower bound means now I'm going to have to take 50 minus 2 and minus 2 because it's 50 minus 2 standard deviations times the standard deviation, 50 minus 2 times 2. Well, when I do that work, I end up getting 46. And the upper bound is going to be 50 plus the 2 standard deviations times the standard deviation. And by the way, in case you're curious as to what my formula is that I'm actually using, it's essentially this: mean minus 2 times the standard deviation, or mean plus 2 times the standard deviation. Or you could write it as mean plus or minus 2 standard deviations, which means up here for this first one, it would be mean plus or minus 1 standard deviation. All right. And our pretty picture says there's our mean. And in this case, we wanted 2 standard deviations. So we're going all the way out to here. And that represents 95%. This represented from here to here was 68%. And remember, all we did was subtract 2. 50 minus 2 is 48, which gave us a 48. We subtract 2 again for the 2 standard deviations, and we get to 46. 50 plus 2 gave us 52. Add 2 again, and we get to 54 for our upper. So that's how that worked out. We have the exact same problem with the same mean equal to 50, the same standard deviation equal to 2, and this time we want to go plus or minus 3 standard deviations. Well, if it's a normal curve, plus or minus 3 will always be the same thing. And it's going to be approximately 99.7%. Approximately 99.7%. Okay? So the first question, or the next part, question 8, what is the lower bound? Well, basically they're saying, hey, we want to take the mean minus 3 standard deviations. Well, in this case, that's 50 minus 3 times our standard deviation was 2. Well, 3 times 2 is 6, so 50 minus 6 is 44. The next one is the upper bound. Well, the upper bound is purely going to be the same thing, but it's going to be 50 plus 3 standard deviations, or 50 plus 3 times 2. So in this case, all the way out here, this is 68%. And then we get to 95%. And then we get way out here, almost not, there's not to the end because we can't get to infinity, 99.7%. And please remember, this goes to positive infinity and negative infinity. And all we did was 50 minus 2 gave us 48. Minus 2 again took us to 46. Minus 2 again took us to 44. And that's what we're looking bound for, because that's our lower bound for 3 standard deviations, because 1, 2, 3 standard deviations. And then 50 plus 2 took us to 52. 52 plus 2 took us to 54. And then 54 plus 2 took us to 56. And this is what we're looking for, because 1, 2, 3 standard deviations above. Because remember, these are just z-scores, where this is 0 z-score, this is up 1, this is up 2, this is up 3, this is down 1, 1 standard deviation below, 2 standard deviations below, and 3 standard deviations. Okay? All right, I hope that helped. Let's flip over to the next side and get going on to the next part of this assignment. And by the way, I cannot stress how much you have to memorize that plus or minus. You know what? I'm going to write this down just because it's so important. Do a different sticky note because I'm going to use that one. But plus or minus 1, 68%. Plus or minus 2, 95%. Plus or minus 3, 99.7%. Now, those are approximate, but they're good enough. Plus or minus 1 standard deviation, 68% for the normal, plus or minus 2 is 95, and plus or minus 3 is 99.7. Okay, number 4, scenario 4. Find the following probabilities and sketch the graph. Well, they want the probability that z is greater than negative 0.47. First off, we have to know something. All z-scores, all of them, have a mean of 0 and a standard deviation of 1. This is something else you have to memorize. All z-scores have a mean of 0, standard deviation of 1. So I'm going to go ahead and put that 0 in there. And by the way, be the stats sensei, learn how to draw these graphs. Negative means it's below. So negative 0.47. And they say we're sketching up. Well, where are we sketching up to? Infinity. Okay, I'm not going to write down the calculator commands. I will show them to you, but here we go. So second vars, norm, CDF. What's the lower part of my shading? Negative 0.47. What's the upper part? I shaded to infinity, so 9 raised to the 99th. Mean is 0, standard deviation of 1. And we get 0.6808. Because we're always going to truncate at 4 decimal places. So negative 0.47. This is and by the way, we're using our LUMO, lower, upper, mean, standard deviation. There's my calculator command that you need to show. That's the same answer I got. All right, the next one. The next one, again, we're working with z-scores. All z-scores, can't stress this enough, have a mean of 0 and a standard deviation equal to 1. So there's my mean is 0. And this is a negative z-score, so it's going to be on the low side because this is a number line. So the negatives are on the low side and the positives are on the high side. And this is my lower, this is my upper, this is my mean. So we're going to go LUMO on this, which is second vars, norm, CDF, lower, negative 0.15, upper, 0.65, mean is 0, standard deviation 1. And we get 0.3017. Now, technically that rounds, but we're truncating. So there it is. My lower bound, negative 0.15. My upper bound, 0.65. Mean is 0. All z-scores, standard deviation 1. Lower, upper, mean, standard deviation, 0.3017. All right. Scenario 5. The flight durations of a certain airline's cross-country routes are approximately normal. Gosh, that means I got to draw a normal curve because they told me they were normal. Might as well get started. That's when I know I have to. With an average flight time of 200. That tells me my mean is 200 and my standard deviation is 15. Okay, so we know that this is centered at 200. That's my mean. What percent of the flights do you expect to have between 120 and 170? Both of those values are below 200. So 120 and 170. Be nice if I had room to write those down below, but I don't, so I'm writing them above. So this is my lower bound. This is my upper bound. Here's my mean. And we know our standard deviation is 15. So second, we're going to do the LUMO. Second vars. Norm CDF. Lower bound. Lower part of my shading was 120. Upper part of my shading was 170. My mean is 200. And my standard deviation is 15. And we get 0.0227. And lower part 120, upper part 170, mean of 200, standard deviation of 15. Lower, upper, mean, standard deviation. By the way, if you write LUMO, you won't forget the order, you won't mess it up, and it's straight off the calculator. What is the likelihood that the flight will be less than 190 minutes? Okay, and you know what? I didn't give, and I should have given it on the one above. I'm going to do it. I am going to go back to it. What they're asking for on this one was the probability that 120 was less than X is less than 170. Because this is my lower bound, this is my upper bound. All right. On number 13, what's likely they'll be less than 190? Well, once again, we're still working with a normal, so we'll go ahead and draw that. And my mean is still 200. My standard deviation is still 15, but we want to know the probability that it'll be less than 170 or 190, excuse me. 190. So this is going to negative infinity. And we want to know the probability that X is less than 190. Okay, so LUMO, second vars, norm, CDF. Lower, well, we go to negative infinity, which is negative 9 raised to the 99th. We shaded up to 190 minutes. Our mean is still 200, standard deviation is 15. And we get 0.2524. Please don't round, please truncate. And once again, this is my LUMO, lower, upper, mean, standard deviation. And we could write negative infinities less than X is less than 190, but we don't like the infinity part, so we drop that off and we just go with X is less than 190. That's my probability statement. Please get in the habit of writing that. Number 14, what's the likelihood that the flight time is more than 250 minutes? Well, once again, we're still working with that same problem where we're still working with a normal. So this is our mean, but we want more than 250. And we're shading all the way up to this time, positive infinity. Oh, and our standard deviation is still 15. So our probability statement is we want the probability that X is greater than 250. So once again, we're going to go do a normal, a LUMO, second vars, norm CDF. My lower bound, the lower part of my shading is 250. The upper part of my shading is 9 raised to the 99th. Means and standard deviation are still the same. And we get 4.2911. Well, I know that probably bothers people, so I'm going to write that down. I'm going to write it down here. 4.2991 e to the negative 4. Please remember that this means, oh, I got to move this for my decimal 4 places. 1 spot, 2 spot, 3 spot, 4 spots. So that means I have 1 0, 2 0, 3 0. All right, and we only go 4 decimal places and truncate, so our answer is going to be 0.004. Okay, or you could look at this and go, hey, whatever that is, I need 1 less. If this has been 5, I need 4. If I need 3, I need 2. But since this is 4, I just need 3 zeros in front of that. So that's my answer. Once again, this is my lower part of my shading, the upper part of my shading, because we're shading to infinity, like Buzz Lightyear, infinity beyond, and then we have our standard deviation, and there's our LUMO. Now, technically, we could say this is the probability that 250 is less than X is less than infinity, but we don't like using infinity when we write these, so we take this and we flip it. So we flip it so that the variable comes first. So the probability that X is greater than 250 is what we're looking for our answer. Okay, and that makes sense because we shaded above 250. So our any value above 250 is what we want to know. Okay. Number 6, the weights of adult golden retrievers are normally distributed. There's that key word. I might as well go ahead and take the time to sketch this because I know I'm going to need it. With a mean of 70. Okay, so we're centered at 70. This is our mean and the standard deviation, and we'll write it off to the side of 8. What's the probability a golden retriever will weigh between 60 and 83 pounds? Well, 60 is below 70 and 83 is above 70. So we're looking for this area right there. So once again, this is going to be a norm CDF, and we'll use the LUMO. So second vars, norm CDF. Lower part of my shading is 60. The upper part of my shading is 83. My mean is 70. And my standard deviation was 8 for the dogs. And we get 0.8422. So 0.8422. My probability statement is, what was my lower? Well, my lower was 60. Probability of 60 is less than X is less than my upper bound of 83. So here it is in pretty. The 60 is my lower, 83 is my upper, my mean is 70. This is my LUMO. And my probability statement is the probability that 60 is less than X is less than 83. Okay, what is the likelihood that it'll weigh over 77 pounds? Well, we're still working with the same problem, so we already know it's normally distributed. And we know that the mean was 70. I should write this off to the side. Mean is 70. Standard deviation was 8. And they want to know probability that it'll weigh over 77. Well, 77 is above 70, so we know this is 77, and we're shading up to theoretical infinity. That infinity dog, he's hugely fat, needs to go on a diet. So our probability statement is the probability that X is greater than 77. All right, probability that X is greater than 77. So second vars, norm CDF, lower bound 77, upper bound infinity. We don't have the infinity button, so we use the 9 raised to the 99th. Mean is 70, standard deviation of 8. That didn't change. And we get 0.1907. So there's a lower part of our shading at 77, shading up to infinity. So lower, upper, mean, standard deviation. And our probability statement is the probability that X is greater than 77, because we shaded everything above 77. Our last problem. What is the chance that the weight of the golden retrievers is less than 65 pounds? Well, we already know it's normal because they told us that in the original problem. So, and we had a mean of 70. Our standard deviation is still the 8, so that part hasn't changed. But we want to know less than 65. Well, 65 is below. So we're shading here, and this goes to negative infinity. So we want the probability that X is less than 65. So second vars, norm CDF, lower bound 65. But it's like, nope, that's not the lower bound. The lower bound's negative infinity. So we put a negative 9 raised to the 99th. Always be careful. 65. Once again, I'm just looking at my statement. Mean 70. Standard deviation is still 8. And we get 0.2659. So here's my lower, my upper, my mean, and my standard deviation. My lower is going to negative infinity. My upper is 65. My mean is 70. Standard deviation, we said, was 8. That was given to us. And we wanted the probability that X is less than 65. And I know technically we'd say it was probability that negative infinity is less than X is less than 65. We don't like using infinity, so we scratch that part out and we just keep the x is less than 65. Okay? All right. Appreciate you watching and look forward to seeing you on the next one. Thank you.